Hey, welcome back to ClearSpot. They're small, often unnoticed, but they hold the power to transform how solar energy is monitored, managed, and optimized. From predicting faults before they happen to squeezing every last watt from your panels, sensors are the true backbone of solar performance. We'll explore how sensors work, what data they collect, and how that data turns into actionable insights that save costs, reduce downtime, and maximize return on investment. A solar plant may look like a simple field of panels, but under the surface lies an intricate digital nervous system. Each sensor plays a specific role, collecting, transmitting, and translating physical conditions into digital signals. Together they provide a full 360-degree picture of what's happening in your solar array, both environmentally and electrically. A pyranometer measures solar irradiance, a temperature sensor monitors panel and ambient temperature, an anemometer measures wind speed, a humidity sensor tracks environmental moisture, and current and voltage sensors record electrical performance. Without these sensors, operators would be blind. You might see a dip in output but have no clue whether it's dust, heat, shading, or a component fault. With sensors, every fluctuation has context.
Think of sensors as the eyes and ears of your solar plant. They don't just collect data, they tell a story about your system's performance.
Raw data by itself isn't useful. It needs to be analyzed and interpreted. Modern solar plants use supervisory control and data acquisition systems, or SCADA, to centralize this sensor information. In SCADA, every data point has meaning. A sudden temperature spike may point to a faulty inverter. A drop in current from a string could indicate shading or damage. When irradiance is high but power output is low, soiling might be the culprit. By correlating sensor readings, operators can pinpoint inefficiencies instantly, instead of waiting for monthly reports or visual inspections.
Every minute your plant underperforms is revenue lost. Sensor data helps you act in real time. Clean panels, replace components, or reroute power flow before small issues become big losses.
You know, one of the biggest revolutions that sensors have enabled is predictive maintenance. Instead of waiting to repair something after a failure, data now allows operators to actually predict when something will fail and fix it beforehand. Machine learning algorithms, well, they analyze patterns in sensor data, identifying those subtle trends that humans might easily miss. For instance, if an inverter starts showing gradual temperature increases or maybe some unusual vibration data, that can trigger early maintenance and help prevent any unexpected downtime.
With predictive analytics, we really move from reactive to proactive operations. It's kind of like giving your solar plant a sixth sense.
So, what's the result of all this? Well, we're talking about lower operations and maintenance costs, longer equipment life, and of course more reliable energy output. Now if we take a look at traditional maintenance, it's pretty much a cycle of waiting for failure, then diagnosing the issue, repairing it, and dealing with downtime, which translates to lost energy. On the other hand, with predictive maintenance, it's all about predicting issues, scheduling the fix, and getting it done with no downtime at all. Sensors play a crucial role in helping plants adapt dynamically to environmental conditions. For example, irradiance sensors enable maximum power point tracking, or MPPT, to make sure the inverter is always operating at peak efficiency. Then there's temperature data, which adjusts performance, expectations, and cooling schedules. In more advanced systems, data from wind and temperature sensors can even inform tracking algorithms that adjust panel tilt to minimize stress while maximizing yield. And, let's not forget about ambient humidity sensors. They can help predict potential corrosion or insulation issues before they actually impact output.
You know, every sensor we have is really helping operators fine-tune performance. And it's not just for today's weather, but it's also about gearing up for tomorrow's forecasts.
The next leap in solar management is, really the integration of AI and IoT. Sensors form the foundation, IoT connects them through the cloud, and AI interprets their data to make automated decisions. AI can, automatically detect anomalies, schedule cleaning, or alert technicians based on predicted failures, all without human intervention. This makes the solar plant not just smart, but actually autonomous.
In the near future, your solar farm will run like a self-driving car, continuously learning, adapting, and optimizing itself through data.
At the end of the day, the goal is simple: maximize returns. Every sensor you install pays you back through better efficiency, reduced downtime, and, well, smarter management. As the solar industry scales, sensor-driven intelligence will define the winners. Those who don't just generate power, but generate insight. Like, share, and subscribe for more solar insights. ClearSpot, smart device, smarter decisions.